Okay, student, this is question number 8. A statement: a student finds a bag of glass marbles and decide to find out the type of glass from which they are made. So the densities of 4 different types of glass are shown. So these are the types of glass: zinc crown and density 2.49, light barium crown 2.87 gram per centimeter, whereas medium barium crown 3.12, dense barium crown 3.5. So the densities are given in this table. So the student chooses 6 marble from the bag. The marbles are added one at a time to a beaker on a balance as shown in the figure at 1.2. So it is actually a physical balance, and a beaker is placed on this balance, and 3 marbles have been placed. You can see in this figure, and there is this figure 1.3. The readings are recorded each time in the table at one at a time and in the same order. The marbles are added to 100 centimeter cube measuring cylinder. So first of all, we will measure the mass of each marble one by one. Just marble 1, then marble number of marbles 2, then number of marbles equal to 3, for number of marble equal to 4. So we will take readings on this balance one by one. So these are the readings. Actually, the readings have been given to you. 0 marble 17.60 gram, and reading on the measuring cylinder when there is no marble, it means only the volume of the water is 40 centimeter cube. So the mass of marble is 0 because there isn't any marble present in the beaker, and similarly the volume of marble is also 0 because only water exists in the first reading in the measuring cylinder. Then put 1 marble inside this and its mass becomes 23.27. And similarly, if we place 1 marble inside this measuring cylinder, the water level will rise and the reading will be 42 instead of 40. So we have to calculate the total mass of the marble in the beaker. So it is very easy. You just have to subtract this 17.60 from 23 point, like this, 23.27 minus 17.60. So it gives you the answer, which is actually the mass of 1 marble. Similarly, if we want to calculate the mass of 2 marbles, we just subtract this 17.6 from 29.31. 29.31 minus 17.60. Actually, you just have to write the answer in these blanks or in these spaces given. Clear? No need to show these subtraction. Just write the answer of these differences. Similarly, subtract 17.60 from this to get the answer and write the answer here, and then subtract 17.60 from 39.5, and then 17.60 to 45. So write the answer here. So you just have to write this, fill this column by just subtracting this initial reading from the readings when we put the marble inside this beaker. Similarly, what is the volume of 1 marble? So again, it is very easy. Just subtract this 42 minus 40. 42 minus 40, and it gives you equal to 2 centimeter cube. Similarly, volume of 2 marbles, 45 minus 40 equal to 5. And then subtract this 40 from 47 to get 7. 49 minus 40 is 9. 51 minus 40 is 11. 53.5 minus 40 gives you 13.5. So we have filled this table. So part A done. On the figure below, plotted graph of total mass of the marbles on the y-axis against the total volume of the marble on the x-axis. So you have been given a graph paper and you need to scale this graph and label x-axis with the total volume of marbles like this. This is x-axis and this is this is y-axis. X-axis we will label it volume of the marbles, total volume of the marbles, total volume of the marbles. And here y-axis, along y-axis, we will write the total mass of the marble. So right here, total mass of the marbles. So this is along y-axis. And now do you have to label? You can see that along this is actually the x-axis and this one is y-axis. So the readings are starts from 40 to 53.5. So you can write here 10 boxes represent 10. Similarly 10 small boxes, 1 2 3 4 5 6 7 8 9 and 10. So this is actually 10. And similarly you write after this 10, I guess either 20, then 30, 40 and so on. Similarly along y-axis the value is starts from 1751. Again you can choose uh, 10 boxes or 5 boxes for 10. So to complete this data given, then we will plot the points like reading on the measuring cylinder. First one, this. So we will see there where is the 40 on x-axis and where is the 17.6 on y-axis. So we plot the point here. Like suppose this is 40 and we have to make the graph 30, 40, and suppose this is 17. So you just have to write this, just plot the point. Similarly plot all the points given and then join these points by the freehand without scale. Clear? So given that density is equal to mass or volume, use your graph to determine the density of the glass. So we have to find the density. So it is very easy. You just have to take the gradient of the graph, because we know that along y-axis it is mass and along x-axis is volume. So gradient gives you density. So obviously it would be a straight line. So we will take 2 points and then gradient of that graph. Gradient is actually the rise over run. We have studied in the physics kinematics chapter. So then write the density, which is calculated by the gradient formula. Then use figure 1.1 to identify the type of glass used to make marble. So you have calculated density, then compare the density with this data given in the table. And if the value is closer to any of these the materials, then write the material name here. So write the type of the glass here. The student had planned the experiment carefully, suggested reason for measuring the mass of the marbles before measuring the volume of the marbles, because we want to, because we didn't want to uh, put the wet marble inside the measuring cylinder. There we need to put the dry ones. That is why we have found, we have measured mass first instead of measuring volume. So this is the reason. Now, second part, suggested reason for choosing 100 centimeter measuring cylinder, because if we choose less than 100 centimeter, it will the water will would overflow. That is why we have chosen this 100 centimeter cube measuring cylinder. In case of less than 100 centimeter cube, the water would overflow when we put the uh, marbles inside the measuring cylinder. The masses are measured more precisely than the volumes. The volume V of the sphere is given. So it is actually the volume of the sphere formula. 4 over 3 is a constant, pi is 3.142, whereas R is the radius of the sphere. Suppose this is sphere. Suppose this is sphere. So this one is the radius of the sphere. So whereas the radius of sphere suggests an accurate method of obtaining the volume of the marbles using this equation, name the measuring instrument used, the physical quantity measured, and how the volume is obtained from the measurement. So measuring instrument used to actually we have to measure the radius or diameter. Diameter is basically. So we will use screw gauge, or I think vernier caliper is better to measure the diameter of the marble. Then physical quantity measured, which one is this? This is length or diameter. So instrument used is vernier caliper, and the physical quantity measured is diameter. How the volume is obtained? First we will divide the diameter by 2 to get the radius, and then put the radius in this formula to get the volume of the sphere. Clear? Again, I'm telling the answer of this. How the volume is obtained? First of all, we will divide the diameter by 2 to get the radius, because we know that radius is actually the half of the diameter. So then we will put that the value of R inside this formula. V is equal to 4 over 3 pi R cube to get the volume. Okay, now question number 6. Figure 10.1 is a full-scale drawing of a small aluminum bar. Actually, aluminum is the material by which this bar has been made. Describe how the density of the aluminum may be determined using the bar in your account, and describe the rating to be taken. So actually, density is equal to mass over volume. So we need to measure the mass first of this, and then uh, take the dimensions by different instruments like meter rule, tape measure, vernier caliper. Depends on the dimension. Depends uh, on the length. Then we will multiply these three lengths, length, width into height, to get the to to find the volume, and then divide mass by the volume to get the density. So you just have to write all of this. This is a description. First of all, measure the mass by the by the physical balance or some kind of electronic balance. Then measure the dimensions, length, width, and height by suitable instruments, and then uh, find the volume by multiplying all of these dimensions. And finally, density can be calculated by dividing the mass by the volume. Straight instrument used to make the readings. So first of all, we will use physical balance or electronic balance, and tape measure. Actually, this is straight, so we must use meter rule. Meter rule vernier calipers or screw gauge as well if the thickness is low. I think thickness is not that small, so I think vernier caliper is better. Vernier caliper, meter rule, and electronic balance. Describe how the density is calculated from the readings. Actually, I have described this. You just have to divide the mass by the volume to get the density. So question number 6 done. All right. Question number 2. When a golf ball is lowered into the measuring cylinder of water, the water level rises by 30 centimeters when the ball is completely submerged. If the ball weighs 33 gram in air, find its density. So actually, the volume of this ball is 30 centimeter cube. So density is equal to mass over volume. So when you write here the formula, density is equal to mass over volume. Put the value here. 33 is actually 33. Yes, 33 is the mass, whereas the volume is 30. So calculate this value by using calculator and write the answer in gram per centimeter cube. This is question number 3. An object has a mass of 300 gram. What is the weight on Earth? So we know that weight is equal to mass into gravitational field strength. So what is mass here? So mass should be written in the kgs. So if it converts this gram into kg, it will become 0. It is difficult to write with this mouse. So it will become 0.3 kg. So write this value here 0.3 and value g is 10. So zero point 0.3 multiplied by 10 gives you 3 newtons. So this is the weight. Similarly, part B, what is the mass on the moon? So mass remains always constant, so mass won't change. So it will remain 300 gram. And what will be its acceleration on the moon when zero point 0.5 Newton resultant force acting on it? So F is equal to ma. Mass remains constant, so acceleration will be F over m. F is 0.5 and mass is what? 0.3 kg. And answer should be this. So it will be 0.6 meter per second square. So this question done as well.